Hello everyone, today I'm going to talk about something of the Brownian motion. First, we are going to talk about go back to the history to see how this phenomenon being discovered and explained. In 1785, Netherlands physicist Jan Ingenhouse first discovered the Brownian motion by watch the carbon dust moving on the ethanol. However, this phenomenon was named after Brown because of the Robert Brown, who discovered the dust and the pollen moving on the water surface in 1828. This phenomenon has not been explained until Albert Einstein, who launched his famous paper in 1905. He thinks that the Brownian motion was happened because of the collide between the water molecule and this large dust and pollen. In 1909, J. Perrin made an experiment which confirmed Albert Einstein's theory. Now we are going to talk about the theory of the Brownian motions. First, Einstein, assuming the conservation of the particle number, he expanded the density, which is the number of the particles per unit volume at the time t in a Taylor series, as shown on the screen. Where the second inequality in the first line is definition of phi. And the second and other items vanish because of the space symmetry, which can give rise to the following relations. As it shows, that's after these relations, where we can do the coefficient after the Laplacian, the second moment of the probability of displacement theta is interpreted as the mass diffusibility d, which the equation of the d is also shown on the screen. Then the density of the Brownian particles rho at point x at time t satisfies the diffusion equation, which is the next line. And after assuming that the n particles start from the original at the initial time t equals 0, the diffusion equation has the solution shown on the screen. The Brownian motion explains the normal motion of the diffusion. However, there are some anomalous diffusion as well. For example, the French mathematician Cauchy first proved that there are other solutions of this diffusion equations, which satisfies the Cauchy distributions. And in 1920, the French mathematician Levy proved that if he proved that there exists a diffusion called the super diffusion, which can also called about the Levy flight. Both the Brownian motion and the anomalous diffusion has some useful usage in the real day life. For example, we can use the Brownian motion to explain the phenomena of the river and what happened in the economics. Also, the anomalous diffusions can explain the albatrosses flies by the roof, the strange behaviors of the albatrosses because it fly by the rules of the anomalous diffusion. Also, the spider monkeys also follow the rules of the super diffusions. For example, we can see from these pictures of the typical trajectories of spider monkeys in the forests of the Mexican displays the steps of the variable lines, which correspond in a diffusive process that is faster than the normal diffusions. An example of such trajectory is shown on the left picture. A magnified part of it is shown on the right picture. This image looks quantitatively similar to the large-scale trajectory, which is an important property of the levee walks. Similar behavior is also found in the foraging habits of other animals, and this could mean that anomalous diffusion offers a better search strategy of that of the normal diffusion, which can help us to protect the wild animals.